Sunday night at like 9:30 p.m. Because nobody does homework at like Friday morning, right? You got to get it done Sunday night. I'm just kidding. You guys are all good students and you get them done ahead of time, right? I realize why the chat is so quiet because Elijah's not here right now. So I'm like, oh, it's easy to keep up on the chat. Okay, so if you recall, we are in chapter 8. We've now gone through 8.1 through 8.4. So 8.2 and 8.3 are graphing and they are on a recording. So if you haven't had a chance to watch that yet, make sure you do. We did 8.1 on Monday. So let me scroll back up there. So 8.1 we talked about, well, we reviewed direct variation, and then we talked about inverse and joint variation and kind of what those look like. And I think everybody agreed that that was pretty straightforward, right? And then we went to 8.4, hence all the scrolling, which is basically simplifying expressions with rational expressions is what I should say. So we did a lot of examples on here. I don't think we did like I don't think we did 7 and 8. So I want to make sure we do 7 and 8. And then I'm going to go a little bit into 8.5. I'm going to do basically the easy part of 8.5. Then we'll save the hard stuff for Monday when we can all be together. So I'm anticipating today should be slightly shorter, but you know, we'll see how that goes. All right, so kind of to warm our brains up, we didn't do 7 and 8, is that right? I could be losing my mind because if we did 7 and 8 already, I'll do an example from the book. Yes, so 8.1 and 8.4, if you want to be all caught up, make sure you through 8.1 through 8.4. Yeah, so somebody remind me, did I do these 2 examples? Or should I do a different example? Okay, all right. So then we should probably do some examples from your homework is what we should do. Thank you, Caitlin and Daniel. Monday was a blur from just coming back to vacation and everything. All right, so let's try number, I don't know, 31. Does that sound good? So I want you guys to try this out too. So if you remember, what we're doing is we are basically simplifying these complex looking fractions, right? And, oh, I guess James can't hear me. That would be a really weird help session if you're just listening, right? All right. Can't talk and type at the same time. There we go. Hopefully he gets that figured out. James, let us know when you can hear us. Oh, maybe he just left and came back. Okay, so let's try out number 31. So we have x squared minus 3x minus 10 divided by x squared minus 2x minus 15. All right, Pen. Times x squared plus 10x. So half the problem with this is writing out the equation, right? They're huge. All right, so the first question is, can I just say, oh, look over here in my first fraction, and there is an x squared and an x squared, so I am going to cross these guys off. Can we do that? So I hear you all chatting at your house. No, right? Cannot do that. And the reason that you can't do that is because they are being subtracted by, well, this x squared is being subtracted by 3x minus 10, and this x squared is being subtracted by 2x minus 15. So we can only cross things off when we're dealing with multiplication. That's the biggest thing. And so right now, the only multiplication I really have going on is across the top, right? I have this polynomial times this polynomial. And I can do that, but that's going to be a whole lot of like distributing and craziness. So I'm hoping before I multiply across the top that somehow I can simplify these quadratic equations and be able to cross some of the terms out. So when we have a quadratic equation, the first kind of thing that your mind wants to go to, well, hopefully that your mind wants to go to, is that you want to be able to factor these equations, because then we have something times something, right? We have two terms that are multiplied together, and then we can cross some things off. So you guys start doing this. I'm going to start doing this. What we're going to do is we're going to factor each quadratic. So what I mean by that is first we're going to take this top guy here, x squared minus 3x minus 10. So x squared minus 3x minus 10. Okay, we're going to unfoil, right? Thankfully, we know to make x squared, we need to do x times x, right? And then to make 10, we could do 1 times 10, or we could do 2 times 5. And we want to end up with a middle term of 3. So in order to end up with a middle term of 3, I think that 2 and 5 are our best chance, right? 2 and 5. Now we'll notice that this is a negative 10. So in order to get a negative 10, one has to be positive and one has to be negative, because a positive times a negative is a negative, right? All right, so then I look at my middle term again. I have a negative 3x. So that means I want my bigger number to be negative. So I want a negative 5 and a positive 2. So back to our Algebra 1 days, right? So then if I want to check it, I can just FOIL, right? X squared, FOIL. So I'm doing FOIL to check that this is right. X squared, my outside is negative 5x. My inside is positive 2x, and my last is negative 10. And so that becomes negative 3x. So what I'm going to do is, instead of x squared minus 3x minus 10 in the numerator, I'm going to write this as x plus 2 times x minus 5. 5. There we go. So then I'm going to keep doing this. So are you guys pretty good with factoring? Like, I'm trying to kind of explain the factoring as I go, but if you're like, oh yeah, easy peasy, I won't take forever doing that. And James, can you hear us now? Yay, you can hear. Good on factoring? Okay. So what we're going to do is take the denominator. Now, what was that tip I told you guys? You're going to kind of look at the one above in the numerator and say, hopefully I can get an x plus 2 or x minus 5 when I factor this, right? It's not an exact science, but, you know, if you can work that out, that would be good. So I've got my x and my x. I've got 15, and I'm thinking we're going to use 3 times 5 because I want to end up with a 2, and 5 minus 3 is 2. So 5 and 3. Oh, and that's convenient. If this is minus and this is positive, then I'm going to be able to cross off on my final expression, right? It's kind of like a puzzle. This section's like a puzzle. Okay. All right, so then my last one. Pick a different color, green. There we go. My last one, I've got to factor x squared plus 10x plus 21. Let's see if I can just do that on the fly. So I've got x, and I have 21. 3 times 7 is 21, right? 3 times 7 is 21. And they're all positive. So now I'm just going to put that over 1 to make it easy for myself. Now can I cross stuff off? Yes, with the question mark. Yes. You guys can't see my face to see if I'm making a face like cross it off or not. Yes, you can. Because now we have, even though you see this addition and subtraction, if you think of each of these units in a parentheses, it's all multiplication, right? It's this times this times this times this divided by this divided by this. So if you think of each of those in the black circle, like that's 1 unit. I have x plus 3 multiplied by x plus 7. Then this is a giant multiplication problem. Okay, and I can cross those whole units off. So I have an x plus 3 up here, and I have an x plus 3 down here. And they cross each other off because it's whatever is contained in those parentheses. Okay, I have an x minus 5 in the numerator and an x minus 5 in the denominator. So I can cross those off. So then all I'm left over with in this crazy mess is x plus 2 times x plus 7. And then we could go ahead and FOIL those if we wanted to write it like x squared plus 9x plus 14. So either form would be okay. All right. How'd you guys feel about that? The biggest trick is realizing here, when I'm up here, I cannot cross things off because I don't have multiplication. So if I change the way that I'm writing my quadratic equations, then I get a multiplication problem. Got it? Awesome. All right. Do you guys want to see a dividing example, or you think you're good? We have. It's just review from, I felt like I was rushing at the end. You have seen this before, Elijah. Okay. So I have a vote for let's do a divide one so that when the book is mean that we can say that we did that. Okay, so let's try number, what do we go to? 40. Let's do number 41. Okay. You guys have to try this at home too. Don't just watch me. Because sometimes if you watch and then you go to try it and you're like, ah. It's the puzzle game, right? 41 is x squared minus x minus 2 divided by x squared plus 4x minus 5 divided by, I think you're going to do stuff. Yeah, Elijah, you're going to do stuff. Okay. So, dun dun dun, we have a division problem. What do we do? Throw our hands in the air and give up. What's division? I don't know how to do it. It's horrible. There you go. Just take the inverse of the second fraction, right? I like this idea, give up. No, it's just like the other one. So for your sake, well, yeah. So what you're going to do, I'll write it out so I'm nice here. What you're going to do is the first fraction stays the same. So you just recognize these are fractions. So all those fraction rules that you learned a long time ago, they all stay the same. So when you're dividing a fraction, it's the same as multiplying by the inverse. And the inverse simply means to flip the numerator and the denominator. So x plus 5x plus 25 over x minus 2. So these are two equivalent problems. Okay, so that's the first thing. So honestly, when you're writing down your homework problems, you could just go straight for writing it as a multiplication problem, right? That's not the hard part. So then now I'm back to just like the example that we just did. I need to simplify. I can't just say, oh, even though it would be super fun to do, x squared and x squared, and there's an x and this becomes 4x. Don't do that, right? Because it's all being added together. Undo, undo, undo. Come on, you can undo. So don't do that. It has to be a multiplication problem, right? So we're going to turn this into a multiplication problem by factoring all of our different terms. So let's see what we can do. Let's actually start with the second part of this equation because it's easier. So x minus 2, I can't do anything like that, but I am going to just write that in parentheses because that way I kind of know that that's grouped together, right? I've got 5x plus 25. Can I simplify that at all? So 5x plus 25. This is like my work off to the side. That's plus 25. Can I factor that? Not really, right? We have to actually go back even before factoring when we were able to pull terms out by reverse distributing, right? So these guys, 5x and 25, have a 5 in common. So we could rewrite this as 5 times x plus 5, right? So now we have another kind of the x plus 5 is a grouping that's being multiplied by 5. All right, so now let's get to the trickier ones, right? They're not that tricky. We've got the numerator over here. That's what I'm looking at. X squared minus x minus 2. So let's factor. It's going to be x and x. I'm hoping for an x minus 2 to match up down here, right? All right, so to make 2, it's definitely 2 times 1. And in order to get a negative 1 here, I want my negative 2 to be bigger to cancel out my positive 1. Okay, so this becomes x minus 2, x plus 1. Now I have my last denominator expression to simplify. X squared plus 4x minus 5 Okay. I'm hoping for an x plus 5, right? All right, so I've got an x and an x. In order to make 5, it's 1 times 5. That's the only way I can do that. And, oh, I want a positive 4, so that works out. Positive 5, negative 1. Okay, so I've got plus 5, x minus 1. So can you see the difference now between, I mean, obviously they look different, but can you see the difference between this expression and how you're not able to cancel out? But all of a sudden, if we rewrite it like this, we have a lot of multiplication going on, right? If you think of what's in those parentheses as individual terms, then it's, we have, you know, x minus 2 times x plus 1 times 5 times x plus 5. So now, because we've written it like this, are we allowed to cancel out? I'm shaking my head, yes. Yeah, right? Perhaps, yeah, because we're multiplying. These are all like these groupings that we're multiplying. So we can take this whole grouping of x plus 5 and x plus 5 in the numerator and denominator, and we can cross them off. Okay, we also have x minus 2 and x minus 2. We cross those off. We have x plus 1 and x minus 1. Those are different terms, right? We can't cross the x and the x off because this is x plus 1 altogether, and this is x minus 1 altogether. So we can't cross those off. You might be tempted to do that. So let's go ahead and multiply. So we're going to have 5 times x plus 1 over x minus 1. So you might be tempted to get all the way to here and then say, oh, well, let me just cross off the x's and I get the negative 5. But that would not be right because x plus 1 is its own term altogether. You kind of have to think of those groupings together. All right. So you guys ready to tackle all these problems? No. I like the inverse of the distributive property too, Elijah. They work together. Like buddies. They're two friends, but they're opposites. I know, but they kind of work together. All right, so the only other thing, if there's any, are there any other questions about anything through 8-4? Why must I do this? Because math, right? All right, so I am going to do a slight little bit of 8-5. I'm going to do the easy part of 8-5. And then we're going to save the hard part for class on Monday, if that makes sense. So basically, this is problems 3 through, yeah, I don't really like my notes for this section. So this is 3, 5, and 7. And I have way too many examples for 3, 5, and 7. Yes, the rest on Monday. So what we're going to talk about is what we just did in 8-4 was technically we were doing multiplying and dividing rational expressions. This copious notes that I had up here, right? We were just basically pulling pulling apart our fractions, and we were simplifying using multiplication and division. Now we're switching to the part of fractions where we're adding and subtracting fractions. So who remembers that from a long time ago? Adding and subtracting fractions. I'm sure your moms or teachers or whoever was helping you made you do a lot of adding, subtracting fractions. Why are we doing this? What? Because it's algebra and fractions together. What can get any better, Elijah? All right, so who remembers anything about adding fractions? What do you have to be able to add or subtract a fraction? Anyone? I know it's in there somewhere. On this one, at least you have to know for the ACT. No, I don't want to say that. There had to be questions about, yes, there we go. Daniel's got it. Same denominator. Okay, so a long time ago, if you had 3/4 plus 1/2, can you add them like they're written? No, because they have different denominators, right? You've got to change 1/2 into 2/4, and then we have the same denominator. And when we add, what we do is we add across the numerators, right? 5, and we keep the same denominator. I actually think that multiplying and dividing fractions is easier than adding and subtracting, right? It's a little bit easier to remember how to multiply and divide. Same goes for subtracting. You have to have the same denominator. So if I had the same problem, but it was subtraction, then it would be 3/4. Yeah, if only this was your algebra problem, right? Equals 1/4. All right, so that's your review of fractions. These examples are actually that easy. That's why I'm doing them on the call today. So what if I have 7 divided by 12x minus 5 divided by 12x? Do I have the same denominator? Yeah, they're both 12x, right? Even though there's an x in there, they're the same denominator. So I can use my same fraction rules. So my denominator stays the same since it's the same denominator. It's 12x. And then across the top, I do 5 minus 7, or 7 minus 5. I can't read today. 7 minus 5, which is 2 over 12x. Can I simplify this a little bit? Yeah, right? 2 over 12x is 1 over 6x. So that's easy. Right? This is all that's left on the call. So let's do these 3 examples because there's too many of these and then I need to do more of the harder ones. So what about this one? 2 divided by 3x squared plus 1 divided by 3x squared. Do they have the same denominator? Yep. So 3x squared. And then across the top, I have 2 plus 1, which is 3. So I can simplify this, and I'm left over with 1 over x squared. Okay, number 3. Scroll down a little. Well, like I said, James, I'm doing the really easy ones today, and then we're going to save the ones that don't have the same denominator for Monday. Right? Yeah. So same denominator, right? X minus 2. And then across the top, I have 4x minus x. So I could rewrite this as, I could pull out x, right? I could rewrite this as x. Oh, duh. I could just rewrite this as 3x. That's not what I meant to do. All right. I should have written this as 3x over x minus 2. Now, can I simplify this at all? Nope, that's right. Can't simplify. Because we have a 3x and then x minus 2, this kind of goes together. All right, last one of the easy ones. And then, like I said, on Monday, we'll tackle unlike denominators. So we've got same denominator, right? So x squared plus 1. The numerator is going to just be 2x squared plus 2. This looks like maybe I could do something with this. These both have a 2 in common, right? So if I simplify this, I have 2 times x squared plus 1 over x squared plus 1. Okay, can I cross these out? And then I'll get to Elijah's comment. Can I cross these guys out? I can, because it's multiplying, right? 2 times this over this, so I can cross this out. So this actual expression equals 2. Doesn't matter what you put in for x, you're always going to get 2. Okay, Elijah, you said, wouldn't you just cross multiply for unlike denominators like normal fractions? So cross multiplying, I think, is what you're talking about, like when you have x over 3 equals 5 over 10 or something like that. So cross multiplying only works when you have the equal sign in there. So you cross across the equal sign. Yeah. But keep that in mind for section 8.6 because you were just one section ahead of yourself. You were just your brain was just working ahead, Elijah. I'm glad that you got the cross multiplying though. That's good. All right, so that's all I wanted to do today, unless you guys want to, keep going on this exciting fraction stuff. On Monday, what we're going to do is we're going to finish 8.5. So that's when we have unlike denominators. And then we're going to do section 8.6, which is solving these expressions. So Elijah already gave you a sneak preview of how we might solve some of these expressions. And then that is it for chapter 8. So your chapter 8 homework will be due, your chapter 8 homework and test will be due 2 Mondays from now. So if you want to keep up on everything, so what is that date? Come on, computer. All right, so Monday we will finish 8.5 and do 8.6. And so your homework and test will be due on March 6th. All right. Thanks for coming today, guys. I'm willing to stay on and answer any questions if you have them. If not, have an awesome day. I hope you guys all get to get outside and enjoy the day. All right, we'll get started on the homework if you haven't done it yet. Hi and bye, Greta. Bye, Caitlin. See you on Monday. Bye, Mackenzie. Have fun in Indianapolis. Did you have any questions, Greta? Well, good luck in your basketball tournament. We basically, all right, great. Have a good day, Greta. See ya. Oh.